Spage. That is the name of the new expansion DLC in Factorio. Not only is it filled to the brim with new and exciting cool content like space stations, new planets that each have their own ecosystem, bunch of new materials and logistical challenges, but it also introduces a huge amount of extra features and reworks to existing mechanics. One of these mechanics, which I'll be focusing on in this video, is the circuit network. It got blessed with a number of reworks, and not just one but two extra buildings in this update. The display panel and the Selector Combinator. If you're interested in anything specific, I'll have timestamps for each section in the video description to skip ahead. But personally speaking, I do recommend getting to know all core changes first. With core changes, I mean all new features that SpaceAge has introduced to circuitry, which affect every building equally. Let's get right into it, starting with abstract wires. Green and red wires aren't craftable items anymore. Instead, they are now represented as abstract items. These buttons on the hotbar are used from this point on to access them. When clicking on either one, the cursor changes to the respective wire color. The way of actually spanning wire connections between buildings has not changed. Click on a starting point, move the cursor, and click on an endpoint, and voila, a wire appears. As a quick side note, copper wires that connect power infrastructure together got sorta the same treatment. An additional button sits on the hotbar for making copper power lines now. In contrast to the two colored wires, the actual item copper cable still remains in the game as a crafting ingredient, you just cannot use it to make power connections anymore. Okay, moving on to messages for future me. The user interface of all combinators has been updated with a few new features. The first I want to cover is the Add Description button. It enables players to note down any important information directly into the machine. Not only text, but also many icons from the game can be put into this description box. The button in the bottom right is used to do so. I can see this feature being especially useful for shared blueprints. Now, instead of manually trying to wrap your head around an unknown creation you got from a random website, the creator of said blueprint can leave helpful comments for each part of the machine, potentially making it much easier to understand and modify to the specific needs. Continuing with UI changes, next in line is routing identified. All combinators now have a small section at the very top for displaying input and output networks. Not only do you get the exact ID for each, but when hovering over the small exclamation mark icon or the ID, the game additionally visualizes the network signal content. I'm sure it can save a bit of time when looking for a specific value inside of a building that is connected to multiple networks at the same time. Alright. Last item on the list would be what's your number? The current signal value for every signal slot is now neatly displayed in the bottom right corner. It's another nice quality of life feature to compact information at the location where it's needed. Say goodbye to temporary power poles that got placed just to get an idea of what the value of the bespoken signal channel is set to. Okay, with the general stuff covered, let's dive further into the details and have a look at changes to combinators one by one. Starting with the Constant Combinator. Just as a quick reminder, this is how the old UI used to look like, and here's the new UI. The static grid of 2 rows, each containing up to 10 signals, has been replaced with a new list of signal sections. You may add and remove as many sections inside one Constant Combinator as you see fit. This is done by using the Add Section button down here and the red trash buttons to the right of every added section. Each section has space for as many distinctive signals as you may want to. In case where there are multiple signals of the same type in different sections, the output that the Constant Combinator will then send out is every individual signal value summed up together. Every section can be toggled on and off freely using the checkmark button in the top left corner. The last and most likely biggest change the devs made is the ability to assign a logistic group to every section. Side note, if you want to know all ins and outs about these groups, I'll link the dev blog post in the description. For now, all we have to know is that every other section with the same group name will share the same values. This whole concept essentially allows for instantaneous remote signal transfer done in a manual fashion. As an example, here's a quick glimpse at one of my survival worlds that I have lying around. What's interesting for us are these defense turret nodes to protect myself from the impending doom that wants to eat my whole factory alive, aka the biter swarm. Inside of every node is a constant combinator that tells the requester chest what ammo type and ammo count each node should stock up to. After I just finished setting up nuclear ammunition, I now want to incorporate such in the defense, but to actually use that type of ammo in the defense nodes, I would either have to manually change every single constant combinator on every node, or make a blueprint from one change node and manually copy-paste this blueprint all over the others. Both operations are a repetitive task that takes a long time and would have to be repeated every single time whenever ammo requirements change. With the power of our new feature, this problem will be no more. I simply make one small change to the constant combinators, which is adding the logistic group node ammo to all of them. From now on, all information will come from this single logistic group. When I modify the signal value inside of it, all other constant combinators that also have bespoken group will receive the same change automatically. Finally, we can sit back and observe how the logistic drones swarm out to fill all requester chests with the updated ammo information simultaneously. Alright, those were the major changes for the constant combinator. Let's move on to the next building, the Arithmetic Combinator. As a quick reminder, this is the old UI for it, here's the new UI. I noticed immediately that the positioning of input and output moved from a vertical arrangement to a horizontal arrangement, where the input is on the left side and the output is on the right. Shortly after, the signal display came into my view. Both incoming and outgoing information is neatly presented on this layer, similar to how you can hover over the exclamation mark icons at the top. Lastly, my view set upon these new checkmark boxes. They serve a simple yet very effective purpose of giving the option to selectively choose the color of the network and its signal value content for each slot to factor in. In simpler words, if I don't want values from the green network to screw with my input, I uncheck the green box. Same with the values coming from the red network, here I uncheck the red box. If both are checked, signals from the same type will be added together and used as the input value, similar to how it used to work. Let me present you a small example. This arithmetic combinator receives an iron ore signal from both network colors. We have 24.5K coming from green and 500 coming from red. I now want to take the value from the green network and divide it by the value of the red network. When I think back before the spage update, this operation wouldn't even be possible to compute with just a single arithmetic combinator. You would need to deploy at least two for doing so. With spage, all I have to do is define my operation, then uncheck the red checkmark on the dividend side, so that he ignores the value 500, and I uncheck the green checkmark on the divisor side, making it ignore the value 24.5K. Lastly, I choose the color that I want to send the output to, in my case, red. This feature of being able to turn on and off both network colors makes future applications more efficient, more compact, and potentially faster. Even if you are not planning to use ominously complicated circuitry in your own playthrough, having bespoken option can still be a helpful quality of life feature to aid in simpler tasks nonetheless. Alright, so far so good. Moving on to the arithmetic's brother, the decider combinator. In the same fashion as earlier, here's the comparison between how it used to look like and the new way. Input and output has moved to a horizontal arrangement, incoming and outgoing information can be seen underneath such, and checkmark boxes have appeared closely around every signal slot. You could say that the UI has been restructured in almost the same way as the arithmetic combinator. When glancing over the last two new buttons though, the add condition and add output button, it may be fairly obvious that our decider combinator got a serious functional upgrade added under the hood. Let me take you on a quick excursus regarding combinator arguments pre-spage. As we all know, the first form every logistic problem takes on would be as an idea in someone's mind. Those ideas are then loosely put into words or other similar text format. This text is then adjusted and filled in with the requirements that the solution should incorporate. When finished, a bespoken idea is then transformed into a mathematical expression. To now bring this expression into the game, we have to abide by the game's limitations for creating such. One aspect in particular has always been a golden rule since back when the logistic network was added to FACTORIO. I'm talking about the numerical ratio between logistical operations in an expression and the amount of combinators needed to calculate such. For years it has always been a 1-to-1 ratio. Take this expression. Due to 3 present operands, our in-game equivalent consists of 3 combinators. Scale it up to 10 input channels that each want to be compared, and our circuit design grows in size accordingly. While still perfectly applicable for the Arithmetic Combinator, our newest feature of being able to add more than one input and or output operation inside all the Selector Combinators breaks this long established rule into a million pieces. This would be a good point to demonstrate how you can set up said new mechanic inside of the game. We'll be starting on the left side. Adding a condition to the list creates a new section with default config. This section represents one condition inside the machine and can be customized to one's needs. Add a second section and a new button that sits sorta in between those two appears. It represents the operator that links said sections together, where the default is OR but can be changed by clicking on it to make it an AND operator instead. With multiple sections present, our decider combinator will only accept our agglomeration of conditions as fulfilled when the most outer level that links everything together returns a value of true. Side note to set statement: when chaining together sections with both types of operators, the game will then create a second hierarchy level to our conditions. What I mean is that all AND conjunctions can only be present directly in contact to our conditions. I'll be calling the spoken area the inner level. All links can be on this inner level too, but are more frequently seen one level higher, which I'll be naming the outer level. By the way, if you ever need to restructure sections inside of the Combinator, said activity can be done anytime by dragging each section at its gridded area to a different location. Be sure though to reevaluate the operators on the left after doing so, since moving sections around will in some cases mess up the initial thought up logic. Like I mentioned a few moments ago, when the operator of the highest hierarchy returns true, our decider combinator will then send out its output. Speaking of output, now would be a good time to go into detail on said topic. Similar to the condition side, the output side also consists of a list which holds individual sections. Each section represents a generated output, similar to how it was before Space Age. Now there's just a bunch of them together in one machine. To get started with it, click on the Add Output button and a new section pops up. Said section can then be further customized. All previous options regarding signal and wildcard channels, plus an attached value of either 1 or the input value, were transferred over into this new style. To now answer the question of, does the order of the output section matter to the combinator? The answer is a simple no. When the left side results in true, all output sections will send out their information immediately at the same time. In reverse, when the conditions result in false, no output will be sent out whatsoever. I'm not gonna lie, getting used to this overhaul took me at least a few hours of trial and error to internalize and get familiar with. Due to Space Age being filled with quite unusual logistical challenges, I would encourage everyone to just go and play around with it for a while, even if you may not fully understand every aspect of it yet. Before we move on to the next building, let me quickly present you 2 practical examples on a familiar circuit building block, but this time implemented with our new style. Example number 1, the SR latch. The SR latch, standing for set reset latch, is a very common building block in circuitry. For creating such in Factorio, we typically use a total of 3 decider combinators. One is responsible to provide the set signal, one is used to generate the reset signal, and the last one acts as a memory cell to our contraption. Quick side note, if you're still unfamiliar with the overall concept, may have a look at Intermediate Circuitry in Factorio Part 1, or have a read through the Factorio wiki article on said topic that I'll leave at the top of the video description. Coming back to our example, with the overhaul present, 2 of the 3 combinators can be tossed aside. The last one is now being able to shoulder our tasks combined. For a threshold application, the internal conditions may look like this. As you can see, the set signal will now be provided by the top condition. The reset signal sits inside of this AND block together with the memory cell condition. Don't forget to wire its own output back to its input to form the physical memory cell structure as well, and voila, we get a complete SR latch. To finish up, here's example number 2, signal channel filtering, also a very essential functionality when dealing with larger amounts of circuit channels. Instead of building an array of combinators that each led through a single channel, one decider combinator can now be configured to do just that. Start off the process by adding every single channel that should be passed on into the output section. Next, be sure that every output is set to the input value option. Lastly, form a condition that will be considered true in every moment to ensure undisrupted transmit of data. I am aware that in rare occasions it might still be better to just negate unwanted signals with arithmetic combinators instead. It really all depends on the specific situation, but most filter applications will get by just fine using this new decider filter method. Alright, enough decider combinator talk for now. From here, the brand new Selector Combinator will take the stage. My first thought after encountering it was, kinda weird, but cool. The outer shell of this lean green fighting machine fits in line with the previous two combinators. All share a 1x2 tile collision box, dual colored I/O ports, a centered display on top that shows the current mode of action, and the small need for electric power. Inner workings do differ quite strongly though. When opening up its menu, we're greeted with this overlay. The header section over here and the add description button are both items that we are already familiar with. Additionally, we can guess that the drop-down menu in the center has to relate to the main functionality of the Selector Combinator. Open it up to reveal following modes of operation. Number 1. Select Input, a mode that sorts all input channels and outputs one of such given by the index value. Here's an example. We get 7 different signal channels from green and red networks. For not making it too complex at the beginning, I'll be leaving the index at its default value of 0 for the moment. Since the channel yellow ammo has currently the highest count, the machine will then output such. If I now increase the index value by 1, we get the second position in our list instead of the first. The rule of thumb here is I want the channel of position x in my list, so the index shall be x minus 1. It is interesting to know that the Selector Combinator does accept signals for providing an index value instead of a static number. When we use an arbitrary channel for our index, said channel is then excluded from the sorted list. Quick example, even though the Selector Combinator receives 3 channels, our output of index 1, which relates to the second position in our ordered list, is not the index channel itself. Instead, we get the next following one. Side note, the direction in which the combinator sorts all channels can be inverted with the slider in the bottom left corner very easily. Now everything is sorted from smallest value up to largest value. Moving on to number 2, count inputs. As the name implies, this mode will count the number of distinctive input channels. Nothing more, nothing less. A small added bonus is the ability to define the signal channel that will transmit the output value of the Selector Combinator. Next mode is number 3, random input. Also very self-explanatory, said mode relays one random input channel to the output side every time the combinator updates. This update interval can be modified with a slider down below or by typing in a number into the text field. This number describes the timeout duration measured in game ticks that the Selector Combinator should wait before generating a new random output. As an example, an interval of 60 will make the combinator change the output channel every second. Setting it to 30 speeds it up twice per second, and setting it to 600 makes the combinator update only every 10 seconds. I'm sure you get the deal by now. Okay, here's number 4, stack size. It's a very handy mode that will send out the stack size of each item channel it receives. The value of the input channel does not matter in this scenario and will not change the output signal for corresponding stack size. Quick side note, all items that cannot be stacked, such as fluids and gases, or channels that correspond to virtual channels, generate no output in this mode of operation. Very similar to the stack size mode is number 5, rocket capacity. As you can guess, every item channel the Selector Combinator receives will be sent out attached with the number of the item a single rocket can hold of said item type. Just like the last mode, any channel that does not correlate to a stackable item will be straight up ignored. Now the last 2 modes are all about quality management, starting with number 6, quality filter. Again, pretty self-explanatory, select a specific quality and a comparison operation for the Selector Combinator to filter all inputs by the defined rule. Such could be filtering for only uncommon channels, or filtering for only rare channels, but also checking for anything that is not a common item, and checking for every epic and above items are all valid rules. Last mode of operation to cover would be number 7, quality transfer. To be honest, this mode is a bit of a strange one to wrap your head around, but it's nothing too irrational. The basic principle is following. Take a signal channel with specified quality and output the signal channel with a different quality but the same value. The target signal is defined in the lower left. Be mindful to also specify the correct signal quality for such. Next, with the help of the direct selection, we specify the new quality that the Selector Combinator should then send out. Before I talk about the second option, let's have a look at a short example. A constant combinator provides multiple signals with varying qualities. I now want to sum up all signals with the same channel type, ignoring their quality. A possible way to solve the spoken problem would be to tell the Selector Combinator to target each channel and output such as common quality. As you can see, all signals and their values are summed up together on the output side. The second option inside of the quality transfer mode, named Select from Signal, makes this operation a bit more dynamic and responsive. You give it a signal channel where the new quality should come from, and it will search inside the input for the highest provided quality of said channel. I'm gonna reuse the first example, but let the combinator get the quality from one of the input channels instead. By selecting iron plates as the quality provider, not much changed in comparison to example number 1, just that the iron plate channel disappeared from the output list. This is due to the fact, similar to how the index mechanism works, that the quality provider channel is taken out of the input list and treated separately. By changing the quality provider to coal, our output quality suddenly changes to rare. As we can see by comparing such to coal on the input side, here the highest coal quality is rare 2. If I go a step further and change the quality provider once again to copper ore, the output changes to uncommon quality, and if I swap out copper ore with plastic bar, the output finally changes to legendary. Alright, with every mode now successfully covered, let's wrap up this section with a contraption where I already put the Selector Combinator to use. This small setup here was my first attempt on figuring out how the new quality mechanic works in combination with crafting and automation. Basically, all you need to know is that the incoming iron ore is filtered by quality and everything above common is put onto a separate belt for smelting. The remaining common iron ore is run through a recycler loop equipped with quality modules to hopefully get a higher rarity on the output side. Now, I could have fed the output of all the recyclers directly back onto the incoming belt, but I wanted to keep all ore neatly stacked inside of the main section. This could be achieved by buffering the output into storage and then restacking the items with stack inserters. Also, yes, I know I used loaders for said purpose. This does make the whole contraption technically unfit for a survival run, but it should suffice just for demonstration purposes. Anyway, I eventually realized a pretty big problem inside of the design related to bespoke stack inserters. You know how normal inserters will deposit their hand's content after a certain amount of inactivity, even when the stack size it can hold is not yet maxed out? Well, our new stack inserters in contrast do not do such. Those will wait as long as it needs for their claw-shaped hand to be filled completely before rotating to the other side and dropping off the goods. I'm talking about this random piece of information because this exact scenario took place inside of the buffer area. The left stack inserter had 4 epic iron ore in its hand, whereas the right stack inserter held a total of a single legendary iron ore piece. Since both were now busy waiting for more items of mentioned kind, tons and tons of common quality iron ore piled up inside of the buffer. At the final moment, where both chests and the belt filled up completely, the entire contraption came to a standstill. Solving this problem meant making sure that the stack inserters would only try to grab item types which had an equal or higher count compared to the inserter's hand size. To now implement said solution, I've used a Selector Combinator which returns the type of item that has the highest count inside of the chest, and a Decider Combinator making sure that our highest signal is at least as large as 16. From this point on, I had no further issues regarding similar problems. Technically, you could argue that one does not even need the Selector Combinator here, so I came up with a second version. In this version, the Selector Combinator still provides the signal with the largest amount inside of the chest. Said signal is then run through two arithmetic combinators in parallel. The first one converts provided value into the letter S signal channel. The second arithmetic combinator merely functions as a frame delay so that both outputs get sent to the stack inserter on the same gate tick. From now on, the signal with the largest item quality is being chosen by the stack inserter, and both stack inserters can also dynamically adjust their hand size in case that channel is lower than 16 due to our letter S channel. Okay, enough theory on stack sizes and item quality. I think it is time to switch to the last building on my list today, the display panel. From the outside, it presents itself as a small grey screen sitting on a metal base with red and green circuit connections. Bespoken base can be surprisingly rotated and mirrored, presumably so that the connection ports can face all four sides, preventing obstruction by wires of the main screen. It's also interesting that, similar to the constant combinator, our display panel can function without any electricity just fine. Open up the UI and following elements will greet you. A large empty text box occupies the center. Above such are two checkmark boxes and a signal slot. I'll get to those in a second. The text box shares the same features as the description box. Icons can be inserted into it by the button in the lower right. When I type in a bit of text and then hover over the display panel from the outside, I can see my written paragraph appearing above it. This hover behavior can be modified by the first checkmark box. When I enable it, Bespoken Display Panel renders its text content all the time as long as my HUD stays in alt mode. The second checkmark box makes the display panel project its content onto the map. Speaking of map, display panels can be remotely accessed from it even if no radar covers the chunk it resides in. Lastly, every panel may also have one distinctive icon assigned to it. That's what the signal slot is for. Said icon will then appear alongside the text, both in my viewport and also on top of the map, given that the second checkmark is still enabled. Alright, we can now leave descriptive information all around the factory, but wouldn't it be even better if the display panel could dynamically adjust its content? We can answer the spoken question quite easily by connecting the display panel to a circuit network. Suddenly, the text and assigned icon transforms into a section with a condition that now resides in a list of such messages. The layout should be quite easy to figure out since it's closely related to the Decider Combinator's functionality. By creating a list with 4 messages in total and giving each a separate condition, I can, for example, make the display panel tell me the rough fill percentage of a stopped train and what type of item this train carries. Real quick, 2 details I want to point out here. First one being that the anything wildcard channel does indeed work as a placeholder for other received signals. Second being that the order of the messages dictates what content the display panel will display when more than one condition is fulfilled at the same time. The game checks each entry internally going from top to bottom. The first entry with a fulfilled condition is then picked and displayed. Here's another example on how display panels could be used. With the help of the wildcard channels and a bit of funky logic, I slapped together a numerical display. Now, for example, I can tell at a quick glance how many legendary gun turrets are in storage or how much common iron ore has already run through the never-ending recycling loop. Keep in mind though, all mentioned examples are most likely just a fraction of the situations that the display panel can assist in. To sum up this video in one sentence, I would go ahead and say that each modification the circuit network received has been a great step in improving its capability and versatility even further beyond, while also giving the player an effective way to integrate and build on existing knowledge on circuitry to tackle all new challenges introduced with Space Age. That said, here should be a good point to stop for today. Apologies for making it a rather lengthy video this time, there was just a bunch of stuff to cover. I do plan on releasing a second video similar to today's topic. It will be all about other non-standard circuitry buildings, such as new features for the radar, impressive adjustments to the crafting machines, new transport belt options that make old sushi belt logic look wrinkly and obsolete, plus many more. As always, thank you so much for watching. I'll be seeing you again next time. Peace!